Hello, everyone. My name is Siddhant Kannan. I'm a third semester computer science and engineering student studying at Sri Venkateshwara College of Engineering. And today we will be discussing binomial probability distribution. Here are some of the basics of the terminologies used. Outcome, the end result of an experiment. Random experiment, experiments whose outcomes are not predictable. Random event. A random event is an outcome or set of outcomes of a random experiment that share a common attribute. Sample space. The sample space is an exhaustive list of all the possible outcomes of an experiment, which is usually denoted by S. Random variables are classified into two types: discrete random variable and continuous random variable. The Bernoulli trial. A trial having only two possible outcomes is called Bernoulli trials. For example, success or failure and the coin toss which has heads or tails. Binomial distribution. The binomial distribution describes discrete, not continuous data resulting from an experiment known as the Bernoulli process. In the figure shown below, the symbols are as follows. N. This starts the count of the number of ways an event can occur. P of x. This is the probability of success for x number of trials. Q to the power n minus x. This is the probability of failure for x number of trials. X factorial. This deletes duplications. N minus x factorial. This ends the count of number of ways an event can occur. A binomial experiment is one that possesses the following properties. The experiment consists of n repeated trials. Each trial results in an outcome that may be classified as a success or a failure, hence the name binomial. The probability of a success, denoted by p, remains constant from trial to trial, and repeated trials are independent. The number of successes x in n trials of a binomial experiment is called a binomial random variable. The probability distribution of the random variable x is called a binomial distribution and is given by the formula p of x is equal to ncx multiplied by p to the power of x multiplied by q to the power of n minus x. Example 1. A die is tossed three times. What is the probability of A. No fives turning up, B. One five, or C. Three fives? This is a binomial distribution because there are only two possible outcomes. We get a 5 or we don't. Now, n, which is the total number of outcomes, is equal to 3 in this particular case for each part. Let x be the number of fives appearing. For a, here x is equal to 0. So p of x is equal to 0 is equal to ncx multiplied by p to the power of x multiplied by q to the power of n minus x, which is equal to 3c0 multiplied by 1 by 6 to the power of 0 multiplied by 5 by 6 to the power of 3, which is equal to 0.5787. Part B, here x is equal to 1. So p of x is equal to 1 is equal to 3c1 multiplied by 1 by 6 to the power of 1 multiplied by 5 by 6 to the power of 2, which is equal to 0.34722. In part C, x is equal to 3. So p of x is equal to 3 is equal to 3c3 multiplied by 1 by 6 cube multiplied by 5 by 6 to the power of 0, which is equal to 4.6296 multiplied by 10 to the power of minus 3. Example 2. Hospital records show that of patients suffering from a certain disease, 75% die of it. What is the probability that of 6 randomly selected patients, 4 will recover? This is also a binomial distribution because there are only two outcomes: the patient dies or not. Let x be the number who recover. In here, n is 6 and x is 4. Let p, the probability of living, be 0.25 and q, the probability of dying, be 0.75. The probability that 4 will recover is as follows. P of x is equal to 4 is equal to 6c4 multiplied by 0.25 to the power of 4 multiplied by 0.75 square is equal to 0.0329595. Binomial frequency distribution. If the binomial probability distribution is multiplied by the number of experiment n, then the distribution is called binomial frequency distribution. If f of x is equal to x and is given by the following equation: mean and variance. Mean, mu, is equal to n multiplied by p. Standard deviation, s, is equal to the square root of the product of n multiplied by p multiplied by q. Variance, s square, is equal to n multiplied by p multiplied by q, where n is the number of fixed trials, p is the probability of success in one of the n trials, q is the probability of failure in one of the n trials. Applications for binomial distributions. Binomial distributions describe the possible number of times that a particular event will occur in a sequence of observations. They are used when we want to know about the occurrence of an event, not its magnitude. For example, in a clinical trial, a patient's condition may improve or not. We study the number of patients who improved, not how much better they feel. Is a person ambitious or not? The binomial distribution describes the number of ambitious persons, not how ambitious they are. In quality control, we assess the number of defective items in a lot of goods, irrespective of the type of defect. We've now come to the end of this video. I hope everyone has learned something. Please like, comment, and subscribe, and I will see you in the next video.